Hello everyone. So in this courses about what? About mathematical tools for thermodynamics 1. So it is a very easy courses as you can see. This courses it is a form of exercise and application. Consider a function of two variables. Two variables. We have here just two variables defined by. So this function is defined by f. Where is the pen? Yes, it is here. It is defined by f of x and y equal x. It is not just x. We need more recipes. So we have here x square and minus y square because this function it is defined by f of x and y. Okay, I hope that's very clear. So first question is to compute partial f over partial r. Partial f over partial r. So we have this notation. This notation, this parenthesis and this theta here means that r, we consider first for this calculation, for calculate this, we consider r a variable and theta constant. So it is not necessary to use this notation, so we can just write this partial f over partial r. But what about this r? This r, it's quite simply one of the polar coordinates. Why exactly polar coordinate and not cylindrical coordinate? Because here we have just two variables, and these two variables are x and y. So we have we work in 2D dimension, two dimension. We have here two dimension. So we have a plane, and because we have just a plane, we use polar coordinates. Okay, so we have here the origin O. This is our origin O, and here we have y-axis, and here we have x-axis, and here, just here, for example, or here, or here, or here, or here, we have this point M, like that. If we want to locate the point M accurately, we need polar coordinates. For example, we have this distance. This distance is r. So as you can see, this is a distance, and all distances are positive. So this distance r, it is always positive or equal 0 if our point M is here. But R, it is not sufficient for to locate accurately, to locate the point M accurately. Because if I tell you, for example, R equal 10 centimeter, one person can draw this, and another person represent this, and another person can also represent this. So it is a problem. Because of that, it is very important to add another coordinate. In polar coordinate, we have two coordinates, and these two coordinates, it is r and theta. R, it is a distance, and theta, it is an angle. There is not unit for theta because it is an angle. So we use radian, for example. But if I tell you that theta equal p over 4, for example, all person, if you have tools, all person draw this, and theta equal pi over 4. So with these two variables, these two coordinates, r and theta, we can to locate the point M accurately. I want the relation between R and X, or yes, the relation between the Cartesian coordinates and the polar coordinates. My Cartesian coordinates here, it is X and Y. My polar coordinates here, it is R and theta. We have O here, Y and X. We have our point M, and here R, and here theta. And remember, this is X and this is Y. So we can see our point M by use the Cartesian coordinate X and Y, or by use R and theta. There is a relation between X, y and r theta. You can see this triangle. Here we have p over 2. So we can use cosine theta and sinus theta. Here we have r, and here we have x. This is x, and this is, as you can see, this is y here. We have y, and here p over 2. So what about cosine theta? So cosine theta, as you can see here, cosine theta, it's x divided by r over r, because we have here P over 2. So this is, so we have here x over r for sinus theta. But for sinus theta, you see theta here, tac, tac, so here y over r. For example, if you have here alpha, you have here p over 2, so for example, here if we have this a and here b and here c, so cosinus alpha equal, as you can see, alpha alpha, so here c, and because of that p over 2 divided by a, sinus alpha equal, we have here b, tac tac, as you can see, it is I here and it is I here, okay, and it is for cosinus theta, as you can see, it's like this, and for sinus theta, as you can, it is an I here. So we have here b over a. So then x equal r cosinus theta and y equal r sinus theta. Therefore, if therefore f of r theta equal r square cosine square theta minus r square sinus square theta. So it is easy to compute partial f over partial r.